Okay, hello everyone. Let's do a short summary on polar coordinates and then we're going to solve one example. So, what do we mean by polar coordinates? That means if I have a point that somewhere, let's call it point P here, then if I wanted to show it in the Cartesian system, I would create an origin, an x-axis, a y-axis. Then I would measure the distance from that point to each of the axes. This would be my x, this would be my y, and I showed that point using the coordinate point P with coordinates x and y. Now, if I want to do this in a polar coordinate system, then I need to show the coordinate system first. And remember, we said in the polar coordinate system, our coordinate system is just one array or one axis and the origin. And then we measure theta from that axis and the distance from that origin. So all we need for our coordinate system is this origin O and this initial ray that we call x, or the x-axis. Now, this is my point. How do I show it? I need r and theta. R is going to be the directed distance from the origin to point P, and theta is the directed angle between the initial ray and the segment OP. Let me show the ray where P or my point is going to be on. So theta is the directed angle. That means I go theta degrees counterclockwise from my initial ray. So this is my initial ray. I go theta degrees and I find the ray that my point is placed on. That's the meaning of this theta. So this is my ray. Let me show it in a different color actually. So I go theta degrees from the initial ray and I get a new ray. This is the new ray, theta degrees from the initial ray. And on this ray, I have to go r, which is the distance, from the origin. So now this is my initial ray. Where is it placed? I go a distance of r from my O to get to P. That's what r and theta mean. Now, the direction of the ray is in this direction. So if my r is positive, my P is going to be on this side of this ray. If r is positive, my P is going to be on this side. And if r is negative, then my point is going to be on this side, on the negative side of this ray. The ray has a direction. That is very important to understand. Another way to look at it is to say I'm trying to find point P This is my coordinate system. I don't know where point P is. How do I find point P? I go to the coordinates. It says r and theta. Let's say r is 2 and theta is pi over 6. Let's say this is my polar coordinate. And I'm looking for this point. So I go to my coordinate system, which is the origin here and this initial ray x. Now, I'm trying to first find the angle, okay, or the ray on which my point is placed. So this is the angle or theta. So starting from my initial ray, I go pi over 60 units, here radians, counterclockwise. I get to this new ray. And remember, if I go this much, this is my new ray. But if I go pi plus pi over 6, I land here. And my ray is going to be the same thing, but the direction is going to be the other direction. That's very important to understand as well. Now let's go back to our question here. So again, I went from my initial ray, the amount of degrees that it says in the coordinate, pi over 6, counterclockwise. I get to this new ray. The direction of this ray is here because this is pi over 6. I still have the same direction here. Now, this 2 tells me I have to go 2 units from the origin because it's positive in the positive direction of this ray. So this way. So 2 units. Let's say this is 1, this is 2. 2 units in the positive way. This gives me P. So this 2 is actually OP, the distance from the origin to point P. Now I found my point with this polar coordinate. Let's do an example to understand this better. Let's say I want to find the polar coordinate for a point for which I have this as the Cartesian coordinate. If this is the Cartesian coordinate, these are x and y. There are 2 ways I can do this. One, which helps me understand it better, is to graph it, okay? So let's first of all find our Cartesian coordinate system. This is the Cartesian coordinate system, x and y. Let's find our point in the Cartesian coordinate system. It says x is -1 and y is +2. So this is the point I'm trying to find the polar coordinates for. Now, I can actually, if I want to find the polar coordinates, I need the polar coordinate system. What I will do, I will place my origin exactly where the origin of the Cartesian system is, O, and I will choose my initial ray as the x-axis, the same as my Cartesian system. So this is now my polar coordinate system. And still my point is here. It hasn't moved. I only need to find r and theta. So I need to find r and theta. That way I have the polar coordinates. Looking at this, I can say this is my point P. We already said the ray that goes from O to P is the ray this point is placed on. So this way I can find my theta first. Theta is the angle between my initial ray, X, and the ray on which my point is placed. When I go from O to P, this ray is the ray I need to measure the angle for. So this is my theta. What is this theta? Let's write the geometry here. This is 1. This is 2. So if I'm looking for that angle theta, theta is going to be this angle, which is pi over 2 plus this angle. Let's call it theta 1. So my theta is pi over 2 plus theta 1. Now let's find theta 1. What is this angle theta 1? Let's go back to the formulas that we had connecting Cartesian and polar coordinate systems. We said that tan of theta, in this one theta 1, is equal to this dimension, which is 1 over this dimension. So it's equal to 1 over 2. From here I can find theta is equal to tan inverse of 1 over 2. And therefore my theta is this value. So I have theta so far. Now I need to find r. What is r? We said r is the directed distance from the origin. Let me get rid of everything else. No, let's just leave everything. So my r is, this is my point. R is the directed distance from the origin to point P. Directed meaning, is it in the positive direction of my ray that I found using theta, or negative? In this case, you can see this is the positive direction. This is the origin. This is the positive direction of the ray. This is the negative direction of the ray. So my point is in the positive direction. So the first thing I understand is that r is positive. And then using this graph, I know that my r is 1 squared plus 2 squared and square root. So it's the square root of 1 squared plus 2 squared, which is this value. That means that my coordinate in the polar coordinate system is positive square root of 5 and this.